Greetings, and again I welcome you to our next discussion. Now, don't panic. I apologize that the last video was a little bit longer than even I realized it was. Truth be told, I got into it and I had no realization that we were approaching an hour, much less going over that. I think you'll find that even though we've combined two sections here, this session will be much shorter than the one that we just finished up. So 8.8 talks about determinants, 8.9 talks about Cramer's rule, and you'll see that they fit together very nicely. One of the many things that we can do with matrix is calculate its determinant. Now, this course, the idea is not to go into depth on what the determinant will do for us, but just to gain a little exposure. That way, those of you heading into linear or finite will have a little experience. And many of you are heading into a business route of some type, and so you'll find that the matrix and the determinant, very nice applications there. So here we go. Let me just read a little bit. Associated with each square matrix A is a number called the determinant of A, denoted same notation we use here with the absolute value bars. This notation should not be confused with that symbol, and so to avoid any misunderstanding, we sometimes will use DTEA in place of the absolute value of A. It just kind of depends on what it is that we're doing as to which notation that we will use. We shall define the determinant of A by beginning with the case in which A has order 1 and then increasing the order one at a time. We shall see in section 8.9 these definitions arise in a natural way when systems of linear equations are solved. Now, if A is a square matrix of order 1, then A has only one element. And so what they're saying here is, if we've got a matrix that just has one element, well, that determinant is its element, which probably comes as no surprise. Let's take a look at a 2 by 2, 2 rows by 2 columns, the matrix here. The definition of this matrix, we take and multiply these two together, and then subtract and multiply these two together, and that gets us our determinant. So finding the determinant of a 2 by 2 matrix is fairly simple. If I call this matrix A, the determinant of A, sometimes denoted the determinant of A, is equal to 2 times 7 minus 3 times 4. So we're looking at 14 minus 12, which is 2. Now, unfortunately, not every matrix that we need to find the determinant of is a 2 by 2 matrix, as you might guess. And so because of that, we need to get some more terminology in here. So A is a square matrix with the elements A sub ij. The minor of an element is the determinant of the matrix of order n minus 1 obtained by deleting row I and column j of the matrix. And then the cofactor is the element where we take -1, raise it to the I plus j, and multiply by the minor. Now at this point you're all probably rolling your eyes and doing the open palm on the head, thinking, whoa, Kev, what's going on? Well, let's take a look at some examples. Let's say that we want the minor along row 1, column 1. So we cross out row 1, column 1, and we look at the determinant of the matrix that's left over, A22, A33 minus A32, A23. Okay, we see that here, and then the cofactor is that minor multiplied by -1 to the 1 plus 1. Here we have the minor of row 1, column 2. Row 1, column 2 is crossed out. We consider the determinant of A21, A23, A31, A33. There's my determinant. And then the cofactor, we take -1. It's always -1, guys, to the row 1, column 2. We add those. Alright, so I'm going to let you kind of read through some of these. It is possible to think about the determinant of A. The cool thing here, guys, is that we can either cross out each time each row, or a particular column. So look what we're doing here. The cofactor of A, 1, 1, row 1, column 1, then cofactor of A, 1, 2, row 1, column 2, cofactor of A, 1, 3, row 1, column 3. And what we do is we take that cofactor and we multiply it by the element, each one as we go. Give you guys a chance to study this example a minute. Let's jump in here and do this example now. Let's think about what we might want to do. Keep in mind that in calculating the determinant of A, if we find the determinant of A along row 1, we're going to have to multiply one element by 2, one element by 1, one element by -1. As I consider all of the rows, I notice that 1 and -1, those are the smallest, easiest numbers to multiply by. You see, if we considered finding the determinant using row 2, we'd have to multiply the elements by 4, 7, and -2. Alright, and so I don't know that we necessarily want to do that. So let's take a look at how to find this determinant. The first thing I'm going to do is I'm going to calculate the cofactor along row 1, column 1. Now, the way we do this is -1 to the 1 plus 1. That's where I get the 1 plus 1. And then I'm going to take this 3 by 3, 2, 1, -1, 4, 7, -2, 2, 4, 6, and I'm going to cross out row 1 and column 1. So this is going to become -1 to the 1 plus 1 is +1 times the determinant of the matrix 2 by 2, 7, -2, 4, 6. So we have 1 times 7 times 6 minus 4 times -2. 1 times 42 plus 8, which is 50. Now let's look at the cofactor along row 1, column 2. We're going to need to take -1 raised to the 1 plus 2. And then here we have 2, 1, -1, 4, 7, -2, and 2, 4, 6. And we're going to cross out row 1, column 2 this time. So what we're looking at is -1 to the 1 plus 2. Well, folks, that's -1 times the determinant of the matrix that looks like 4, -2, 2, 6. So what we've got here is -1 times 4 times 6 minus 2 times -2. Alright, and we think about what we have here. -1 times 24 plus 4, we're looking at -28. And then finally we're going to look at the cofactor along row 1, column 3. -1 to the 1 plus 3. Here's my matrix, 2, 1, -1, 4, 7, -2, 2, 4, 6. So -1 to the 1 plus 3 is 4, -1 to the 4 is 1. Now I'm going to knock out row 1, column 3 this time, so I'm looking at the determinant of my 2 row by 2 column matrix 4, 7, 2, 4. This gives me 1 times 4 times 4 minus 2 times 7. 1 times 4 times 4 is 16 minus 14. 16 minus 14 is 2. 1 times 2 is 2. A 3 by 3 matrix, we need to find 3 cofactors. We have succeeded in doing that. Now, the determinant of my matrix A is equal to element in row 1, column 1 times that particular cofactor, plus the element in row 1, column 2 times that particular cofactor, plus the element in row 1, column 3 times that particular cofactor. And so we've got 2 from row 1, column 1 times a cofactor of 50 plus 1 times that particular cofactor, which is negative 28, plus row 1, column 3, which is negative 1, and that particular cofactor is 2. And so my sum here, which is my determinant, is 70. So there's my determinant of a 3 by 3 matrix. Let's take a look at one more example that will work together. Now guys, as you noticed maybe, we can find cofactors along a row or a column. We want to look for the row or column that has the smallest numbers in it. And if you can find a row or a column with a 0 in it, that's what you want to do. And we notice that we've got a 0 here in row 3. So we are going to look at, if we call this matrix A, the determinant of A. We are going to look at element row 3, column 1 times that particular cofactor, plus the element in row 3, column 2 times that particular cofactor, plus the element in row 3, column 3 times that particular cofactor. And so let's find our cofactors here. The cofactor of, well, first, before we do that, guys, let's note something here. The element in row 3, column 1 is negative 1. The element in row 3, column 2, row 3, column 2 is 0. So that's a cofactor I don't even need to calculate. And then the element in row 3, column 3 is 2. And so I've only got 2 cofactors here that I need to calculate. The cofactor for row 1, column 3, which is negative 1 to the 3 plus 1, times, now let's look at my matrix, 2, negative 3, negative 2, negative 1, negative 4, negative 3, negative 1, 0, 2. Now what I'm going to do is I'm going to knock out row 3, column 1. So this is negative 1 times the determinant of negative 3, negative 2, negative 4, negative 3. And so let's see, this is negative 1 times negative 3 times negative 3 minus negative 4 times negative 2, negative 1 times 9 minus 8, negative 1 times 1 is negative 1. So there's that particular cofactor, and we don't really care what this particular cofactor is. So let's find the cofactor, row 3, column 3, negative 1 to the 3 plus 3. Here's my matrix once again, 2, negative 3, negative 2, negative 1, negative 4, negative 3, negative 1, 0, 2. Alright, so we've got negative 1 to the 3 plus 3, which is 1. And we're going to need to knock out row 3, column 3. So we've got 2, negative 3, negative 1, negative 4. So we've got 1 times 2 times negative 4 minus negative 1 times negative 3. Well, this gives me 1 times negative 4 minus 3, which is negative 7. So negative 1 times negative 7 gives us a positive 7. So this is 2 times 7. 1 plus 14 is 15, and that is our determinant of the matrix A. Well, goodness, folks, I notice here that I've made a mistake. Let's take a quick peek at this here. 2 times negative 4 is negative 8. There we go. And now negative 8 minus 3 is negative 11. This looks a little better. And so we'll fix that. Fix these two results. My apologies for the mistake here. Negative 11. And so we'll put a negative 11 up here. Negative 22 So we're going to get negative 22 here, and let me switch colors. Negative 22 here. And I just noticed something, guys, and you guys have probably noticed this all along. Negative 1 to the 3 plus 1, that's going to be a positive 1, and so this needs to be a positive 1, and this needs to be a positive 1, positive 1, and a positive 1. So this makes this right here a positive 1. So negative 1 times 1 is negative 1 minus 22 gives me a determinant of negative 23. So take a minute. I apologize there for the oversight. Make sure you're okay with what we did there. And now we are going to, in a very limited way, use Cramer's rule to solve systems of two equations and two unknowns. Okay, I've given you a few problems to work there for homework, and we can go over those. I don't really have any for class discussion with finding the determinants by hand there. We can just go over some if we need to, and I'm sure we'll do that. We've got a way here to solve systems of equations that uses determinants. And this is a way that among mathematicians some feel is not real useful anymore. Some disciplines, though, still use Cramer's rule, and so we're going to give you a very limited exposure to Cramer's rule at this point. And Cramer's rule is what section 8.9 is about. So when you get ready to work the problems here in a little bit, class discussion, you will want to be looking at section 8.9 here and not section 8.8 to get your problems from Cramer's rule. Actually, this is fairly straightforward. I think you're going to like it. We've got a system of two equations, two unknowns. Alright, coefficients of x, coefficients of y, the constants. What you do when you're trying to find x and y using Cramer's rule, you take your coefficient matrix. Remember we talked about that in the last session? Your coefficient matrix, the determinant of that matrix is your denominator when you're finding both the x and the y. The numerator, when you're finding the x and the y, if you're looking for x, you're going to take the coefficients of the x and replace them with these constants. And for y, the numerator, you're going to take the coefficients of the y and replace them with the constants. Alright, so let's take a look at what this means here. If I'm looking for x, first of all, I'm going to take the determinant of, I'm looking for x, so I'm going to replace 4 and 2 with negative 11 and 5. I'm going to leave the coefficients of the y's alone. I'm going to put that determinant over the determinant of the coefficient matrix. So I've got 4, 2 in the first column. I've got negative 5, 1 in the second. And so now I find my determinant, negative 11 times 1 minus 5 times negative 5 over 4 times 1 minus 2 times negative 5. Negative 11 plus 25 over 4 plus 10. So this gives me 14 over 14, which is 1. Now remember, guys, that's what x equals. And now we're going to solve for y. When we're solving for y using Cramer's rule, we leave the coefficients of the x now on top, and we replace the coefficients of the y with our constants, negative 11 and 5. And the determinant is the determinant of the coefficient matrix is my bottom once again. So 4 and then 2 below it, negative 5 and 1 below it. So we've got On top we've got 4 times 5 minus 2 times negative 11, 20 plus 22 equals 42. And on bottom we still have 14 because it's the same calculation as before. 4 times 1 minus 2 times negative 5. 42 over 14 is 3. You can check the work, but our solution here is the ordered pair 1, 3. Questions there? Alright, and then let's look at one more example where we use Cramer's rule to solve the system. We have looking for x. On top, we're going to take the determinant of the matrix where I replace the coefficients of the x with my constants here. So negative 22 and 6, and then here I've got negative 10 and 1. So we do the determinant here, negative 22 times 1 minus 6 times negative 10 over the determinant of the coefficient matrix. So this is 8, negative 10, 3, 1. So this gives me 8 times 1 minus 3 times negative 10, negative 22 plus 60 over 8 plus 30. 60 minus 22 is 38. 8 plus 30 is 38. Once again, my x is 1. And then for the y, the coefficients of the x's stay in this time. The coefficients of the y's get subbed out. We get a negative 22 and a 6. Here we get the coefficient matrix once again, 8, 3, negative 10, 1. And so here we have 8 times 6 minus 3 times negative 22 over 8 times 1 minus 3 times negative 10. Well, this time we get 48 plus 66 over 38. And so we've got 114 over 38, which gives me, wow, 3. So once again, we've got a solution of 1, 3. And this concludes these two sections, guys. The big thing you've got to learn here, I think the thing that will take the longest time, is how to use the minor and the cofactor to find the matrix, or find the determinant of a 3 by 3 matrix. So certainly have questions, let me know, and we'll be happy to go over these. But you know, for the test, two things: know how to use Cramer's rule, know how to calculate by hand a determinant of a 3 by 3 matrix.